It's Brian Page back at you for my second rendition and my second edition of a presentation on medical physiology. Before we start, I just want to give a little shout out to my boys, Finn and Rowan. They really love YouTube, so they're going to be probably watching this over and over again because it'd be so exciting. So, hey, Finn. Hey, Rowan. Good to see you. And I'm actually doing this for a class. So I'm a student at the University of New England, and as part of our requirements, we have to put together a presentation on different topics. And in this topic, we have to put together on the human reproductive system. By trade, I'm a clinical psychologist, and my goal is to go back to school. Well, I'm in school now. My goal is to be a licensed prescribing psychologist, so I'm able to prescribe medication in conjunction with providing psychotherapy, etc. So today I'm going to talk to you a little bit about is the hormonal control of implantation and early embryonic development. So let's kind of get started and we'll get into the topic at hand. So, what I'm going to be talking about today are some essential hormones that are really integral for implantation and early embryonic development. So, there's four main hormones that are essential for this process. The first is progesterone, the second is estrogen, the third is human chorionic gonadotropin, or also called HCG. And the fourth, but not least, hormone is the human chorionic somatotropin, or HCS. So this is a nice depiction from the Silverthorne textbook for this class, for the medical physiology class. I'm trying to move my picture out of the way here. So this depiction is really awesome because it kind of takes a look at the fallopian tubes and the female uterus, and it kind of goes from ovulation all the way to implantation. So this process takes an average of 7 days, but between 5 and 9 days. So here's the ovary, and the egg is obviously produced within the ovary. Um, Sperm comes down the fallopian tube, and there's a fertilization that takes place. I'm not going to get into the details about that because we're going to get more into the implantation process and the embryonic development. But once it's fertilized, the egg becomes a zygote, or starts to develop into an embryo. And it takes this long journey down this fallopian tube. It takes about 2 to 4 days. And during this journey down the fallopian tube, cell division takes place by mitosis. So by the time the zygote reaches the uterus, which is over here, it's something called a blastocyst. So a blastocyst is a ball of cells composed of about approximately 100 cells. So once the blastocyst reaches the uterus, that's when implantation occurs. So, like I said before, on average, implantation takes about 7 days to occur. And we'll talk a little bit about the hormones that are essential for implantation to occur next. So I kind of like this. It's a turtle depiction, kind of traveling at your own pace, taking your own time, because the embryo does take its time in that journey down the fallopian tube. Um, so, like I said, the dividing embryo takes about 4 to 5 days to move from the fallopian tube into the uterine cavity. The essential hormone that is integral in this process is progesterone, as I mentioned before. So, under the influence of progesterone, smooth muscle within that fallopian tube relaxes and gradually moves that embryo down the fallopian tube. Like I said before, it's a slow process, but slow and steady pace wins the race. So, as I said earlier, blastocyst does develop when it reaches the uterus, and that's a ball of about approximately 100 cells. So, there's different layers within this blastocyst. The outer layer forms the chorion, which will form eventually the placenta. And the inner layer is what the embryo is going to develop from. And then three extra embryonic membranes also are developed from the inner layer. So the ambion, which becomes the ambionic sac, the allotosis, and the yolk sac. So those are all integral in the development of the embryo into a fetus and also obviously the newborn baby. As I said multiple times, the implantation on average occurs about 7 days after that egg is fertilized with the sperm. So another essential hormone, as I said before, is the human chorionic gonadotropin. I'm going to refer to it as HCG from this forward because it's a little easier to pronounce. So the blastocyst implants. As that happens, the placenta begins to form, and it's the placenta that secretes several hormones that prevent menstruation from occurring during pregnancy. So one of these essential hormones is the HCG. And this is actually what the pregnancy tests pick up when when a woman's taking a pregnancy test. It's HCG that is detected by this test. So HCG is a peptide hormone that's developed by the developing placenta. So HCG keeps the corpus luteum active. So the corpus luteum is a ball of cells that's created with fertilization that actually releases progesterone. So HCG binds with luteinizing hormone receptors to influence the corpus luteum to keep producing progesterone. So by doing that, it keeps the endometrium, which is the lining of the uterus, intact as opposed to sloughing off. So that's what happens when menstruation occurs. There's a sloughing off of the endometrium, and pregnancy cannot occur. So it's the HCG production, in turn producing progesterone, that kind of keeps this endometrium intact. So by the 7th week of embryonic development, the placenta actually takes over the progesterone secretion, and the corpus luteum is no longer needed and it disintegrates. Secretion of HCG reached its peak at 3 months. Another essential function of HCG is also stimulates testosterone production by the developing testes, particularly in male embryos, male fetuses. HCG has actually hit the news cycle relatively recently, I guess not really, but within past 10 years, in conjunction with testosterone use for performance enhancing drugs. Actually, in 2009, Manny Ramirez, he was a Dodgers outfielder that got in trouble for having HCG in his system. So why would he have a human chorionic gonadotropin in his system? Well, actually, this kind of stimulates testosterone production. So a lot of individuals who use steroids, testosterone will, after a cycle, use HCG to stimulate the testes to produce testosterone naturally. So it's kind of a way to get around the potential side effects of injecting testosterone. So just an interesting fact that I thought I'd bring to the table. Not really related, but kind of. Another hormone that's essential in the development of the embryo and implantation, well, more of the development of the embryo, is the human chorionic somatotropin, or HCS. So it's another peptide hormone, and similar to growth hormone and prolactin. It's also called human placental lactogen, particularly because it's very essential in the development of breast tissue and also lactation within the mother. So another integral part of this hormone, the HCS, is that it alters the mother's glucose and fatty acid metabolism to support fetal growth. So that's really essential. Some have connected this hormone to gestational diabetes, in that the mother who normally doesn't have diabetes develops diabetes with pregnancy. So it's an interesting tip. The last hormones that are integral and essential in the development of the embryo are estrogen and progesterone. I already mentioned progesterone, but just as a reminder that these hormones are produced continuously throughout pregnancy, first by the corpus luteum, as I said, and then by the placenta once the corpus luteum is disintegrated. Feedback, a negative feedback loop prevents actually another follicle from being developed. So that's what estrogen and progesterone kind of do. In particular, like I said, progesterone is essential in maintaining the endometrium, so menses don't occur or the period of the woman doesn't occur. So that would support pregnancy. It also helps to suppress the uterine contractions that may occur. So it'll prevent early labor and delivery. So estrogen is also important in the development of milk secreting ducts in the developing mother. So let me move my face. In summary, the dividing embryo takes about 4 to 5 days to move down the fallopian tube. And on average, 7 days later, implantation occurs within the uterine wall. There are four main hormones that control the implantation and the early development of the embryo. Like I mentioned, human chorionic gonadotropin, HCG. That's particularly important to ensure that the endometrium is maintained and that menses do not occur throughout pregnancy. Human chorionic somatotropin is essential for the development of breast milk, lactation. So that's very essential. And then progesterone and estrogen are important for both those factors as well to help the embryo develop, in addition to prevent menses and the sloughing off of the endometrium to occur. So that's all I have. I hope this was entertaining or exciting presentation. Hopefully, people besides my professor watch it. If they don't, that's okay. I'm just learning the trade and I need some practice, but it was good practice. So I appreciate you listening. Have a good day.